Welcome to the ninth episode of Under the Hood. So today we are going to be going really under the hood, and you'll get some insights on some of the things we don't talk very often about, but are really important. So we are going to talk about our engineering systems and all the things that. Some of the things that we are doing to support our developers and some of the machinery behind the scene and in our development team. And today to talk about that, I have Jonas with us. Welcome, Jonas.
Thank you, Vincent.
So Jonas, tell us a little bit about yourself. What are you doing in the BC team, and what's your role?
Yeah, so I'm the engineer manager for the engineering systems teams. And I joined Microsoft about 15 years ago, and for the past 12 years, I've been running the engineering systems team over here in different names. I think we were called Build System one point at a time, and infrastructure at some point, and now it's engineering systems. Right?
Infrastructure is still something that...
Infrastructure is still something that sticks.
Yeah, sticks a little bit. Yeah. But it's a lot more than just infrastructure. What do you?
Yeah, and so when we talk about infrastructure, people associate that with other things like, hey, can you help me with my laptop? Or my Windows isn't working, or sorry, I don't know really much about those things.
So just to be clear, you don't do any IT stuff?
Well, I do at home for family.
So you can actually fix printers?
Yeah, well, that's the one thing I cannot fix. That's the one thing that nobody can fix.
All right.
Yeah.
Okay, so so your team is called Engineering Systems,
yes.
right?
Yes.
So let's start with talking a little bit about builds. Right,
yes.
because that's something that
we do quite a bit of.
Quite a bit of, right?
Yes. Yes.
So how many? What do we build? What do you build, and how often? And
Yeah. So obviously we build the product. Yeah.
So Business Central.
Business Central as a product, and then we have about 100 repositories with code bases that we build on a regular basis.
Okay.
And I think my team owns about 70 different build pipelines.
So 100 Git
100 Git repositories we have that are active and churn builds more or less daily. And not all of them are owned by my team, obviously, but we kind of oversee the build processes on a lot of them, make sure that they work, that they produce what they need to, the outputs, the official builds, that those builds are set up correctly, securely, by following compliance rules and like all of these things.
So what are examples? Can you give some examples of what this repo?
So for instance, there's a repository for the developer tools team, the compiler. There's
all the Visual Studio Code.
All the Visual Studio Code parts. There's a specific repository for the application developer team where we have the app team. There's a different repository for the platform runtime pieces. There are repositories for engineering systems, like for the build system itself is its own repository and its own code base. And there's all of these different repositories. Like the control plane is a big part as well, right? We have multiple repositories for the services that it takes to provision and run cloud services.
So that's the whole machinery to orchestrate the cloud.
To orchestrate service. So when a customer signs up for a new environment, to provision those environments, to get it deployed, when a customer connects to the environment, figuring out where to connect in the backend, etc. The repositories for all of these different services. Some of them are lumped together in one repository. Some of them are like one service, one repository. We have a kind of a mixed model.
So if you're familiar with what we ship on the DVD, so these parts are not shipped on DVD, obviously.
Correct.
Right? So some of the pieces you mentioned before, like the NST and things like
the
that.
The application, the NST, the installer.
They're on the DVD and on the part that we ship openly, but all the code that is orchestrating the SaaS service is actually not shipped, obviously.
No,
but that's also a large part of our code base. Right?
Yeah, if you look at the amount of people we have working on the product, like the things we ship to customers that are being used by customers, that's a lot of people. But a lot of people is also working on the underlying infrastructure, engineering systems, and control plane to make it possible for users to sign up to the product and use the product and upgrade to new versions, get hot fixes, and report issues and get help and support and everything. So there's a lot of code and work that goes into that part of the system as well.
So do you have some stats on these builds? How many different versions are we building? So we actually let's start somewhere else. We went to Git We didn't use Git
Yes.
you
True.
know, from the beginning, right?
Yes.
Obviously.
Yeah.
So we had another internal
Yes.
internal product
Yes.
which has some similar capability
Yeah.
than Git, but as things evolved, Git was much more mature and became an industry standard.
Yeah.
So we moved to Git some years ago,
Yes.
and you were part of that effort, which was not quite
Significant amount of
yeah.
work. Yes.
Yeah. So can you talk a little bit about that?
Yeah. Yeah, so we came from this source control system called Source Depot, which is Microsoft internally only. It's not available outside of Microsoft. So many years ago, Microsoft purchased the source code for a system called Perforce, also known as P4. It's a centralized source control system, which Microsoft took, productized internally, added some features, scalability, performance, other features missing. And then more or less entire Microsoft was running on Source Depot for many, many years. And being a centralized system, you know that there are some pros and cons to that. It doesn't have any good offline experience, so you went flying or working without internet connection. You couldn't edit files and stuff. Some things were quite complicated. And then kind of Git came along and became an industry standard, and Microsoft started adopting open source much more, becoming much more friendly towards open source, and kind of figured it doesn't make sense that we continue investing in our own source control system anymore. So let's move to something standard. And Microsoft decided Git is the answer, which good decision, a couple of years later. So we had to migrate this really old monorepo we had with all of the legacy code base for Navision at that time, right, into Git. And if you took a single copy of just the latest versions of the code and binaries and stuff in Source Depot, that would take up something like 30 gigabytes on your disk.
For Business Central, for example.
For just Business Central source code.
Yeah.
So we had a ton of binaries and source code in that repository. And Git doesn't really do binaries well. It does text really well, but not binaries. So we had a really complicated process of moving binaries out of Source Depot, creating symlinks on disk to make it look like it actually was still on the disk. So then moving the code into Git so we could build based on the code base in Git, and symlinks to the binaries, and then gradually moving these things out into packages and redoing the code base and kind of moving that way into Git. But a long, interesting project. We had to replay history from old Source Depot into Git to some extent so we can get history. And then we had to write bridges so people could go and look in history from Git all the way back to the beginning of SourceApe. So we would go and open up the old SourceApe browser to look at history when you surpassed the history we had in Git. So,
yeah, and you still have requirements to be able to build older versions for various, compliance, but also support purposes. Like somebody has a bug on an old version, we should be able to potentially fix it, especially if it's a security bug. So all the versions we support, at least officially back in time, we need to be able to, at all time, be able to build them. Should some, for example, a security incident occur, we would have to provide a patch for it. So that puts a lot of requirement on your team.
Yeah, we keep on building old versions quite a bit still to be able to do security fixes, like you mentioned.
If needed.
If needed,
So with the, if you're familiar with Git, you know that there is this concept of branches. So we have quite a few branches in our repo.
Definitely. So there are many branches which we call official branches, and official branches are branches where we publish official builds out of. So those are builds we ship to customers in one way or another, different shapes and forms, right? And then obviously there are tons of branches across repositories for when people do feature development, they share work between teams, or they do private tests, etc. So, but not counting that, there are still a lot of branches. And I actually brought a slide we can look at.
Yeah, you have some numbers and statistics on this.
Yeah, a little bit of numbers on the amount of active branches we have. So on the y-axis here, you can see the different branches that we maintain and are active, where we produce builds. And there's about 30 of them, so 30 different versions where we produce builds out of Business Central. So
it's more or less, is it fair to say that there's at least, at a minimum, one branch per version?
Yes.
We have, like even the minor versions, we have a branch for that. Right?
Yeah, exactly. And on the x-axis, you can see the activity in terms of official builds on these branches. So how often do we assemble the entire product and make it ready for shipping? You can see so in the last 60 days, we did that almost 800 times in master. And in the 25x branch, we did it almost 600 times.
So what's master?
So master and main is the same thing. That's where we develop the next version of Business Central.
Okay, so it's not yet
it's not shipped to
version,
customers.
It's not shipped, but
Exactly.
That's where
the active development happens.
happening,
the new stuff is happening. And eventually we branch out for releases and we ship out of release branches so we can go and hot fix issues that customers.
So we have master, which all our developers work on.
Yes.
And then when we ship, say 25,
then we branch out for 25.
We branch out for 25, but then everybody continues working.
They continue in master, and then as they develop new features, if some of those features are also shipped in a minor, then they backport that from the master branch into the 25, 1 or 2 branch or whatever, whenever they want those things to ship.
All right.
Yeah.
And then for each of these branches, we build the entire product.
We do, yeah, over and over again, every time we need it.
Like every day or every night or all the
well,
time?
I mean, so if you look at the main branch, for instance, we built it 800 times in the last 2 months. So it's 20 times a day or something. We produce new builds, new versions. So every time anybody churns the product, if you check a new code to the product, every single change produces a new build, which we deploy to test environments, run all the tests on them, etc., to make sure that it works. Yeah.
And do we build? What about the language version? I mean,
they're included.
has many language versions.
Yeah, so with every commit, we rebuild every single language version.
Okay, so
everything, all 30-something languages.
Okay, so that's a lot of builds.
We use a lot of compute power engineering systems teams. Like we have up to 3,000 machines running on a daily basis, doing nothing but building and testing the product.
Okay, and it's all automated?
It's 100% automated. The developer checks in code, gets it reviewed, and eventually the build is produced and uploaded and uploaded into test environments, etc.
Yeah, so just to be clear, the automation basically is what your team has been developing and maintaining and so you mentioned tests, and there's also some tests that gets run also on a regular basis, also in an automated fashion.
Yeah. So I also have a slide on that. So let's take a look at this one. So this slide shows us, on the x-axis, it shows us the day from January 1st to January 23rd. And on the y-axis, you can see the amount of tests we run on those every single day. So January 1st, and a lot of people are working, we just run some stability jobs and tests, and we run about 20 million test cases. But then people get back slowly, they get back into work, etc. So if you look at January 9, for instance, we ran almost 18 million tests on that single day on the product. So, and this is a combination of running tests on different versions, localizations, and different test jobs, body build jobs, PR validation, official jobs, performance tests, all sorts of things. So we run, I think on average, 40 million tests every day, something like that.
Wow. So what happens when one of these tests fails?
So it depends. If they fail on your pull request validation, then we reject your code changes. Then we say you can't check it in.
So we're talking about gating basically changes,
exactly.
right?
Yeah.
So any change that breaks the build, or even before that. So if there's a build
so they
error,
don't get into the build unless the test passes. But the PR validation is quite complicated. Imagine every official build runs about 500,000 test cases. So with the PR validation, we do churn-based test selection. So depending on what you change in the product, we run different tests and use that to determine if you broke something or not.
So you have to some heuristic to determine which test you'll be running, depending on which part of the code.
So we collect code coverage for all of the tests that runs in the product, and then we also know all of the inputs and outputs. So we collect statistics from the file system, so we know every single file that's been read by any build task, and all the outputs that were produced by that build task. So if you modify 3 files as part of your pull request, we can tell these files were part of these build tasks, these build jobs. So now we need to rerun those and all the children of those and all the tests associated with those parts of the tasks.
Oh, pretty impressive. So
it's a rather large system.
So it's fair to say, so you're working a lot with automation in general.
Yes.
So it's fair to say that your team is pretty good at that.
Yes. I mean, that's what we do. Like a core tenet of our team is to minimize or remove any manual processes. It wouldn't be scalable to have a team doing any of these things manually.
So so everything when you basically
all the things I'm talking about is automated.
It's all running automated.
And when any of those processes fail, we get signals and bugs and things like that. And that's where we sometimes have to step into the manual things. When things are failing, we need to investigate and mitigate or fix bugs and rerun things. So then we might kick off a new automation process again.
Manually, then.
We started manual, but then it's automated.
But then it runs automatically.
Then it just runs automatically. Yes.
I got it. What about security? You also have a important role in ensuring our products are secure, right?
Yeah. So if you look in the last couple of years, supply chain attacks is on the rise. So there are lots of examples where companies manage to compromise engineering systems, packaging systems, NPM, NuGet, and all these things. And companies get bad code into the build environments, and then attackers manage to move laterally from the build systems, etc.
So that's a different type of attack.
Yes.
People maybe the traditional.
They don't attack the production system. They attack the system before it heads into production.
Which is probably more efficient if you succeed. Because
if you can sneak bad code into a product, you can do bad things.
Yeah, for sure.
Imagine, I don't know, sales processing. If you could, charge the customer twice, once for the actual merchandise they're buying, and one to my account or something.
So that would be really, really bad.
Yes.
But then, luckily, you are there to prevent this from happening.
Yeah, well, we do our best. We haven't, as far as we know, we haven't had any attacks. But we spend a significant amount of time on security.
So can you give a few examples of what these activities are?
Yeah, so there's a lot of work currently with these safe future initiatives within Microsoft, which has a lot of different work streams in how we lock down systems. So that's part of it. But then we also do other things like we baseline all security settings we have across all our repositories. We make sure nobody has permissions to anything they shouldn't have. No code gets into the repository without at least one full-time employee signs off on it. And if it's release branches, at least 2 different persons need to sign off on it. So we manage all of these policies and make sure that nobody has access to things they shouldn't have. And anytime any permissions are changed in the system, we get notified and we review these new permission changes, and we either roll them back or we update the baselines. So I think we review these baselines almost every day when things are changing to make sure that you don't have permissions to something you shouldn't have. We make sure nobody has persistent access to build pipelines, release pipelines, code, anything like that. Feeds. If you can inject something into a build feed, NuGet, NPM, whatever, then you can sneak in code into the build. So we need to make sure that can't happen. So we run component governance and all the types of tools on all the packages we use to make sure they haven't been compromised. And
so we know exactly which component we are using and where they come from. And all.
Yes, exactly. And then we generate SBOMs and things to indicate what's part of the build, every single version that is an input for the build system.
What about certificates? You also, we're using all sorts of certificates to.
So those certificates are generated by Microsoft through the OneCert system, and we don't have access to those. They're stored in key vaults only, and then we have specific identities that the build system runs under for the parts that needs those certificates that can read them from that key vault. And then they get auto-rotated frequently.
So they change on a regular basis.
They change on a regular basis.
Even if somebody could hold of one of these certificates.
If somebody somehow managed to find a gap and steal one of those certificates, we can just rotate it immediately. And it happens automatically, but if we learn that the certificate was leaked, we can rotate it as well to make sure they can't use it for anything bad.
So I know it's not the case anymore, but at some stage, you had this idea of using BC as a platform for building these tools. So a lot of these tools you are talking about are automation tools, but they still require maybe sometimes some UI to do some of the. For example, you were mentioning maybe restart an automation or restart a build or something. So you had this idea at some stage. So tell us a little bit about that. I think that's a good story.
Yeah. So one other thing we did many years ago was that as Microsoft became more and more cloud, our build system moved from being an in-house hosted type of build system to run in the cloud itself. And then we had to create our own build system, essentially, right? And when you create your own build system, we didn't really want to spend time building a UI for that build system. And we found out that BC is really good at data-driven UI presentation, declarative data-driven UI presentation. So we essentially connected Business Central on top of the build system database and created our entities that would represent bills and jobs and these things in BC. And then our engineers could use BC, kind of like dogfooding BC, to look at the build system, look at the tasks running, how much was left, look at log files from bills and all these things.
So you basically you removed all the things in BC, like there was no customer.
We removed
no sales orders.
Yeah. We had our own application.
Basically no really ERP.
No ERP, yeah. So we took that out to build
traditional ERP
at
least, but you use BC to manage or build resources in a sense, right?
And we got the UI for free, so we didn't have to build that UI, and it would work on a phone and different browsers and all these things. Like we're not experts on building UI and dealing with JavaScript and HTML, etc. But BC is really good at that.
So you can have good UI.
Yes, really good UI with filtering and sorting and all of these things.
But we don't use this anymore.
No, unfortunately not. No. We don't.
Okay, so we move to some more
so one of the things
we're trying approach, or
we're integrating more and more into Azure DevOps for the internal stuff, and then for the external open source things we're running on GitHub. So we want to be as close to the retail experience as possible. It's easier when you hire new people. It's easier for our engineers if they're looking for documentation, etc. So we integrate into these systems, Azure DevOps and GitHub instead.
Okay,
it makes more sense longer term. To be as
it makes sense.
Retail as possible.
And building your own things.
Building and maintaining and updating. Yes.
Yeah. So can you tell us, do you have any, so what's going on right now? What are you working on? Do you have any projects you are excited about, you want to tell us about?
Yeah, so we have a couple of different ones. So we do some improvements internally. One of the things I'm quite excited about is something we call project test tolerance. As you imagine, if you run 80 million test cases every day, if just a single of those are unstable, then you get into some issues, right? So this test tolerance project can track tests across multiple different branches and different builds and different people. It can detect through heuristics if the failure you had on your branch is related to your changes, or if it's related to some other instabilities, like, I don't know, February 29th is one of those leap years. It's typically a day where some tests no longer work because they never thought about leap years. Or you go from September to October, you go from a one-digit month to a two-digit month. There are cases like that where developers make mistakes in their test cases. And one thing that's really frustrating for developers is if they try to get their code into the build and it fails, but it doesn't fail on their code, it fails on something else. So with this, we can kind of detect that things are failing multiple places for different people without changes, and we no longer have to treat that as a failure. We can instead ignore it and just warn about it. So that's one thing, test tolerance, super interesting thing. Then more on the external side of things, we also work on ALGo for GitHub.
Okay.
Which is like this kind of similar engineering system, but for partners they can bring their own code and they can build applications and extensions to BC. And one thing the team is working on that Freddie is driving now is incremental builds. So if you have a lot of projects that you're building as part of your builds, your CI/CD pipelines, and you only modify one of them, we would only rebuild that one and we'd take the outputs from the previous build for the other inputs.
So faster turnaround time.
Much faster turnaround time. And also that means that when you deploy your changes to your test environments or to your sandbox, you only have to redeploy one app instead of 10 of them or 50 of them. So the turnaround time, the feedback loop becomes much quicker.
Yeah, so talking about which one of the, some of the charter of your team is also to support our developers internally. From the BC engineering team. So you're doing a lot of things for keeping them happy
Well, we try.
Yeah. So what are the things you provide? What kind of service do you provide to our developers? Can you give us a few examples?
Yeah, so we listen to a lot of their feedback, and we listen to what is it that they find frustrating, annoying with the engineering system. So like our team owns everything from the environment where they write their code to getting the code actually shipped to customers through DVDs or installed as hotfixes in SaaS, etc. So we get feedback around all of these things, and then sometimes we onboard some new services for developer environments, like Microsoft new DevOps offerings. Then we make sure we create images that are good for our engineers to work on.
So if I'm a developer in BC, like let's say I'm a newly hired, right?
Yes.
I can just start developing. I don't need to install anything.
So you just go to a website and you say, okay, create DevBox, and you give it a name and you give a size, essentially. How big do you want it to be? Do you want 8 CPUs, 16 CPUs, or 32 CPUs? And you deploy it, and the image it deploys with has all of the tools installed that you need to build the code.
And then you can start coding right away.
Yeah, you clone the Git repository, and then you can start coding directly. You don't need to care about the dependencies.
So you have SQL installed.
There's SQL, and there's compilers, and like
Visual Studio Code.
SDKs and Visual Studio Code.
All the things that you require.
The things that you normally would need. Yeah.
And I can tell you an anecdote about that, because one of people in our team was trying to set up a machine, so basically his own laptop with the whole environment. Then of course you can do that yourself, but then you need to install the product. You need to install all the things, the tools, the SQL Server, Visual Studio Code, all the SDKs, and all that. That's doable. But then when compiling, it was our app. It was really, really slow to deploy, right? And so we kind of talked about it as that's weird, because on my dev box that's pretty fast. And we were talking a factor, 10 or something, or maybe not 10, but from 5 minutes to 15 minutes, right? And then we figure out that there's a whole bunch of virus scanning that happens
on your laptop.
On your laptop. So we, especially things around the NST that get scanned, and these are pretty big files. So that we figured out that was kind of the problem. And
so when we set up these dev boxes, we add exclusions for the virus scanner for specific folders and types of and processes based on our experiences of what needs to be done.
So just to be clear, this is still very secure. This is not we do virus scanning of everything. It's just because
this is just a development environment. The code doesn't ship without going through a lot of testing and scanning.
And typically you are building. We trust the code we write ourselves.
Yes.
This is the code that does not get scanned, because this is what gets changed typically when you
it gets reviewed by at least multiple people will review your code before it gets to production.
So that's pretty cool. I just saw recently also your team just made a new improvement to our deployment system, so we would have. All developers now have a fully deployed
shared test tenant.
Test tenant they can access practically right away with the latest bits from master.
So that's another example of such an improvement we do when we hear about the frustration around getting easy access to test deployment. So all of the developers can access all of the official builds get deployed, and they can just go to the browser and they go to a URL, and then they can pick between which builds they want to test and get signed into BC for that one automatically.
As opposed to before, they would
have to go through the sign up flow,
and it will take some time, and before you actually had a full environment. Now it's just readily available. That's pretty cool. So they can test and
and the same thing for private branches. So if you're working on a feature in your team or yourself, you can submit a test job that does this deployment for you, and when that's done, it shows up in this environment as well.
That's pretty
cool. You don't have to sign up to that as well. You just go into the browser, you can test your latest code.
I haven't tried yet, but I'm sure I will. It's nice. It's a great improvement. Yeah. So I think quite a few of our partners out there have different systems similar to ours at different levels. Some of them are simpler, some of them are quite complex.
Yes.
So do you have any advice for partners in building engineering systems, and how should they go about it? Is that something they should invest a lot into?
I would say stay away from it if you can. No, I would piggyback on one that is already out there.
Something like Azure DevOps?
Yeah, so Azure DevOps, and if they're working on AL code, I would probably go for something like ALGo for GitHub, Alpaca, AL DevOps, and like there are solutions out there. I would recommend building on those instead of creating your own from scratch.
Right.
It's become very complicated to keep these things secure and staying up to date with all the things happening in the industry these days.
So unless you have very special needs, and even with that, I mean, these
I would rather customize an already available system than create my own these days.
But when you say it's a good thing to have at a minimum some automated build, so you can build on a regular basis.
Yeah, I don't understand how you would be able to work in today's landscape without having automated builds, tests, deployments that happens.
So some
every
version
time
control.
you check in. Version control you need builds, you need a pull request or a review process for looking at the code, getting it reviewed. You need a way to test your code and deploy it and these things.
Yeah.
With some of these systems like ALGo for GitHub, these things they come out of the box.
Yeah,
even the test execution and deployment to sandboxes and these things, you get that for free versus spending. Then you can spend your time on what it is you want, like business logic, business value that is better off.
Yeah, we'll put some links in the comments on the documentation of ALGo for GitHub. Yeah.
Yes. Yeah. Which is, by the way, where we're trying to move our own application team development. So we're gradually moving them out of our internal Azure DevOps solution. Slowly, it takes time. We have a large legacy system, but eventually the goal is to have our app team
dogfooding that actually.
Using ALGo for GitHub dogfooding and doing all of the development in the public, in the open source space. So contributing with partners and sharing some of the work, taking contributions from them, etc. Yeah.
All right, Jonas, thank you for sharing all these insights on maybe another part of BC that's less known.
Yes, definitely.
I hope you enjoyed this episode, and thank you for watching.